All right, welcome back. So we are now looking at the last subtest for chapter 12. Let me just remind you what happened in chapter 12.2. So 12.1 was about goodness of fit, and that provided the basis for our last test, which was the test for independence of categories or two variables. And it's very important for you to remember that these were two qualitative variables on the same population. So, for example, if you go back to the test for independence of health and happiness, we looked at a single individual who answered two questions. And then we're saying that one population, is there some kind of relationship between the response, how they answered one question and another? In other words, between one qualitative variable and another. So this is going to help you determine what kind of test you have, because now we're going to perform essentially the same steps, but we're going to call it something else. So again, we have a single population with multiple qualitative variables. What that yielded was a test for the independence of the two variables. So for example, here we looked at students and we categorized students by their area of study and the Myers-Briggs preference. So we're looking at a single population and we're basically asking is area of study independent of preference. Now we're going to go ahead and change gears and literally do the same procedure, same steps, same even commands. But now we're basically going to have different groups, different populations. And what we're going to look at those populations, we're going to look at the same qualitative variables. And what that's going to yield, it's going to yield the equality of proportions test. So are the proportions the same? So that's what's called the homogeneity proportions. You basically ask, are the proportions for each population? So again, you're looking at different populations. Are they equal? So it'll be the equality of the proportions across those different populations. And so it's actually pretty easy to see this because you're going to essentially stratify. You're going to group a population at large into either row 1 or row 2. So male, female is a classic one. At the beginning of the class, we went ahead and we saw that we also could maybe use race. So race is here. We could have also used whether they agree or disagree with a statement. And now the question is going to be, again, we're looking at different populations. Do each population have the same proportion of success for category 1 or category 2 or category 3? So again, it's some qualitative variable. Okay, so there's a bunch of different ways for you to stratify this. Some of the most common ones are going to be by gender or some other more general classification. So let's go ahead and see an example. So here we ask, do men and women have the same distribution of living arrangements? So it's actually pretty interesting. I'm not sure if any of you have thought about this, but that's part of the reason why I wanted to include this. So do men and women, do they have like the same living arrangements? So here is the example. Suppose that 250 randomly selected male college students and 300 randomly selected female college students were asked about their living arrangements. They select dormitory, apartment, with parents, or other. The results are shown below. And here's our question. Do males and females college students have the same distribution of living arrangements? What I want to point out is that the rows are fixed because remember, you're looking at this population. You already know the number. We know that the number of males was 250 and the number of females was 300. So that's very different from before. Okay, before the only number that we were very sure of was the grand total, because that was your sample size, that you then went ahead and stratified according to two qualitative variables. Here it's different. We're looking at two different groups, and that's why I have the size of each group here in the row. All right, now the question, when they're asking about the proportion of living arrangements, they're essentially just asking the following, same as before. If you were to look at dormitory and see how many people respond with yes, is the proportion of males that are going to respond to the dormitory question going to be very similar to the proportion of females that respond to the dormitory? So we're basically asking, are these proportions the same? Because if they are, then that means that there is agreement across these populations, the male-female population, that live in dormitory. You can do the same thing for apartment. So is the proportion of males who live in an apartment very similar to the proportion of females who live in an apartment? And so this actually explains sort of why it's going to be the same test as before. Because if you remember, we started by finding the proportion, even though we didn't use it when we derived the independence test. We started by finding the proportion in a cell. And so now we're going to go ahead and essentially do the same thing. Okay, so if you know the proportion of the cell, you can find the expected count, and therefore you can go ahead and do a goodness of fit test. Okay, so really the only thing that's going to change here, they're going to ask about distribution of living arrangements. One keyword to look out for is if you have different populations. Or groups. And then they're asking you, are the groups the same? So in other words, they're saying, are the proportions of success for the different categories the same across populations? So your null hypothesis is going to be that the proportion of subjects in each category is the same. This essentially relates to the independence requirement. And so the way that we can think about that is PAI is equal to PBI, where they're using ABG, the group. So here it'll be male and then group one. Then it'll be female and then group one. Proportion of male, group two, or quality two, proportion of female, quality two. So you're essentially asking, if I look at group I, is the proportion for population A the same as the proportion for population B, the same as the proportion for population G? So we're essentially saying all proportions are equal. So if we let P of M1 be the proportion of males that live in the dormitory and P of F1 be the proportion of females that live in the dormitory and so on, then our hypothesis test is going to be, there's a couple ways of writing this. So let's write it in words because I think I see it mathematically here. Notice P of M1 is the same as P of F1. P of M2 is the same as P of F2. So in other words, male and females have the same proportion for each category or for each living arrangement. So here in words, it'll be that males and females have the same proportion across different living arrangements. It's really hard to more or less think of the grammar, but the keyword here is just that males and females are the same. Same proportion. The alternative, of course, is going to be that they're not the same. So males and females do not have the same proportion of living arrangement across these different categories, right? Dormitory, apartment with parents. Mathematically, we represent that with there's at least one difference in one category. So at least one category is different. All right, and now that we have that settled, let's go ahead and continue with our test. Remember, this is the same test as so the equality of proportion, same test as independence. So once you got your hypothesis, you want to go ahead and check the requirements. And the requirements were all about the expected count. So we want each expected count greater than 1 and no more than 20% to be less than 5. All right, to do that, we need to throw this information into StackCrunch, which I already have here. And the commands will be exactly the same. So we'll go to tables, contingency with summary. So dorm, apartment, parents, other. And we want to visualize the expected count. So there's our expected count and our test statistics. So I'm just going to go ahead and actually write that down right now, just so that I don't have to go back to StackCrunch. So we shouldn't have to go back to StackCrunch anymore. All right, and if you remember what I told you about the expected counts, there will usually be space when you're doing this on paper to write it in. So let's go ahead and write it in, just to demonstrate to whoever's looking at this that you have actually looked at the expected counts. So notice that there's actually pretty good agreement between these expected counts. Maybe not here, but the first ones definitely did. Ooh, oh no, 62.27. 74.73. And so this is another benefit. As you're writing it in, you can see whether there is any category that is way, way different. So I got a feeling here that there is a difference just because of the level of the gap here in the data. There's several gaps in these typed out observed values and the expected value. So the dormitory, I think, is expected. There's very good agreement here. In the apartment, yeah, it looks like with parents and with other, there's a lot of disagreement. But with dormitory and apartments, there seems to be very good agreement. So let's go ahead and write down our test. So obviously, as I was writing that in, I observed that all of my expected counts are greater than 1, and all of them are actually greater than 5. So I don't got to worry about that. And let me just write out my chi-square stat. So it's 10.12, and the p-value. Ooh, okay, p-value was 0.0175. And so we're going to go ahead and reject the null. There is sufficient evidence that there is at least one category that has different proportions across these populations. And you can probably guess that it's going to be the with parents or with other. Okay, so we can definitely go ahead and examine that further. We'll do that in a little bit. All right. And let's go ahead and just wrap this up. So let's see. The degrees of freedom is going to be row minus 1 times column minus 1. So there were 2 rows because it's male, female, and then columns, that was the number of categories that we had. So we had 1, 2, 3, 4. We had 4 different categories there. So this will be 1 times 3, so that's 3. So there's a chi-square distribution with 3 degrees of freedom. Still a right tail test. I'm guessing alpha is 0.05. And we can actually go ahead and find this if we had to. But we already know that the p-value is smaller than alpha. So therefore, we're going to reject the null. So notice I went kind of fast because it was the same test as before. The only difference is the hypothesis mentions proportions are equal, or you could have even said same distribution. Remember, same distribution says that the proportions are equal, that it doesn't matter what row that you're in or the column that you're in. Really, I guess here would be row. But now what I want to do is I want to essentially go back and see, well, which of these is different? So let's maybe look at not the expected count, but maybe let's look at the column percentage. So we can look at the total of individuals who live with parents. What's the fraction that are male? And then what's the fraction that are female? All right, so you can confirm that this is in fact being done by the kind of living. So it says if we only look at this group, ooh, check that out. If you only look at that group, it's very easy to say, so this is what we did in in previous earlier chapters. We only looked at two groups like this, and we only looked at one category. So people who live with their parents, we can see that the proportion of males is 0.3577, and the proportion of females who live with their parents is 0.6423. So that's a very big difference, right? Proportion of females is double than the proportion of males. So that's pretty strong evidence there that there's actually a difference in the proportion of individuals here, or sorry, in the proportion of the different populations, which is male, female, who live with their parents. And we can go ahead and see that in the apartment, it's very close, 49 and 50. Dorm, I would say that maybe this is still kind of close, and that maybe this right here is what's responsible for us rejecting the null hypothesis. Because then here we have pretty large differences as well. The proportion of males who have other living arrangements is 56% versus 43. So you know what? These are actually pretty big. Only the apartment one seems to have equality of proportions. So if you did a a two proportion test, two prop z test, then for apartments, I think you would fail to reject, but for the other groups, you'll probably reject. All right, that is it for that example. We'll do one more, but we're more or less done with that. So thank you for joining. I'll see you in the next video.